Okay, let's look at the rules for what happens when we're trying to keep track of our significant digits and we use multiplication or division. So rounding products and quotients, what we'll do is we'll keep the lowest accuracy. So when we're adding and subtracting, we kept the lowest precision, that is the place value of the last one. When we're multiplying and dividing, what we'll do is we'll keep the lowest accuracy. So we'll keep the number of significant digits. This one has 3 significant digits. This value has 2 significant digits. So when I multiply them together, 4.35 times 3.6 gives us 15.66. In order to round this to the appropriate number of significant digits, I need to go with the lowest accuracy, and you can see this one only has 2 decimal places of accuracy. So that means this number, the resulting number, needs to be rounded to 2 decimal places of accuracy, which is 16. Again, it looks like we are rounding this number off, but the reason for that is we can't be sure that we're this close. This kind of implies that we have that number to the nearest tenth, or to the nearest hundredth of, well, whatever our units are here. It implies we have the number to the nearest hundredth, but actually we only would know that number to the nearest whole number. Alright, if we have 375 miles divided by 65 hours, 375 miles divided by 65 hours. I'll go ahead and do the division here. 375 divided by 65 gives us 5.769 whatever, ... And for our units, we have miles on the top and hours on the bottom, so we're in miles per hour here. But of course, you know, this number, we have way more accuracy than is actually implied here. This number has 3 significant digits, this one has 2 significant digits, so we should be rounding this number off to the nearest 2 significant digits. We should go ahead and call this 5.8 miles per hour. Again, because we don't know that it's this accurate. Just because we came up with a digit that goes to infinite, you know, we could take this number out to thousands of decimal places of accuracy, but that's not saying that we actually know that it's that accurate, because this 65, by writing 65 there, we're saying that it's 65 hours to the nearest hour. It could be 64 hours and, I don't know, 31 minutes. Or it could be 65 hours and 29 minutes. Could be, you know, anywhere in that range. Alright. Let's see, 7.2 times 0.48. These are both in inches, so I'll go ahead and just type that in here. 7.2 times 0.48 gives me 3.456. I take inches times inches, so those are going to be square inches. And I need to round this off to the appropriate number of significant digits. You can see that's what the instruction is for all of these. Round to the appropriate number of significant digits. This is 2, this is 2, so they both have 2 significant digits, which means I can go ahead and round this off and call this 3.5 square inches. Alright, this number, 2450 divided by, oh no, it's tons per square foot times the number of square feet. So 2450 times 3178, we get 7786,100. We're taking tons per square foot times square feet. So a ton per square foot, this is a measurement of pressure. Maybe we're talking about, I don't know, an aquarium or maybe a pool. Each square foot of that pool has a certain amount of weight on it. And, you know, we're saying this is the number of square feet of that pool. So we're trying to figure out the total weight that's being pushed down, the total weight that's being expressed on that pool. In any case, this number right here has 1, 2, 3, 4, 5 decimal places of accuracy. Again, those zeros don't count. Whereas it should have, let's see, this number has 3 decimal places of accuracy, the 2, the 4, the 5, not that 0. This one has 4. We should go ahead and round this off to 3 decimal places of accuracy, which is going to be right here. So this is going to be 779, and then I'll just fill in the rest with zeros. So 4 zeros there. We get 7.79 million, and this should be tons. because the square feet and the square feet cancel here.